So in this video, we'll be looking at an example problem using recursion. The problem that we'll be addressing is the factorial of a number. The factorial of a number is the multiplication of all the numbers between 1 and the number itself. For example, the factorial of 3 is 3 into 2 into 1, and the factorial of 2 is 2 into 1. Some prerequisite that you need to know is that 0 factorial is 1, and the general form of factorial is written as n factorial is equal to n into n minus 1 factorial. Now let's look at how to do this problem without using recursion. So here we've used a while loop. So the first thing we've done is we've defined a function called factorial with an input n. So we start with an if-else loop where if n is less than 0, we return 0 because factorials can only be written for whole numbers. Now else if n is equal to 0 or n is equal to 1, we return 1 because as we discussed, 0 factorial and 1 factorial is 1. Now, in the else part, this is the main part of the function. So first, we're defining a variable called fact, and we're assigning it the value 1. While n is greater than 1, factorial is equal to factorial into n. So we're taking this 1 and it's multiplied by n. Then it goes to the next line where n becomes n minus 1. And we return this factorial. But this part is repeated while n is greater than 1 till n is 0 or 1. So let's see, if we give it a number 5, it'll go here. N is not less than 0 and n is not 0 and n is not 1. So it'll go into the else part. Now fact is equal to 1 and n is 5. So 5 is greater than 1. We get fact is equal to 1 into 5 and then n becomes n minus 1. So n becomes 4. Now this will go back and we'll get fact is equal to 5 into 4 because fact now has the value 5 into n, which we got 4 from this line. This will continue till we get 1. So this is how you do this problem without using recursion. Now, if we want to use recursion, you can already see that the code is way shorter. So what we've done here is we've defined a same function, factorial, with the input n. Here we've just had to use a simple if-else statement. So if n is equal to 0 or n is equal to 1, we return 1, as I explained in the previous part. Now else, we just call the same function again. So we return n into factorial of n minus 1. Now this will call the same function again, but with n minus 1 as the input, after we've already taken the given n. So for example, if we take 5 again, it'll go directly to the else part, and we will get 5. So this will be 5 first, and we'll get factorial of 4 into factorial of 4. So it'll go back, it'll come here, and now n will be 5. So, n will be 4, and this will become 3. So this will keep going till we reach n is equal to 1, in which case we'll get 1. Then this will get backtracked, and we'll get 5 into 4 into 3 into 2 into 1, which is 120. Now let's look at some of the comparisons between recursion and iteration. So in recursion, like we just saw, the function calls itself, while in an iteration, a set of instructions are repeatedly executed. In recursion, we saw that a function was repeatedly called, and in iteration, you saw that we used 2 loops. To stop a recursion, we leave a base case. For example, here the base case was this, while to terminate an iteration, there needs to be a condition given, which needs to be satisfied for the function to stop calling. So recursion is used when code size needs to be small and time complexity is not an issue, and iteration is used when time complexity needs to be balanced against an expanded code size. And like we saw, in recursion, the code is really small, and in iteration, the code is really large.